Hey everyone, welcome to my channel. Today we are gonna learn about units and measurements. Measurements are a part of our lives. When you brush your teeth, you spread a measured amount of toothpaste on the brush. You make the measurement by simply looking at the amount of toothpaste that comes out of the tube. You take almost the same amount every day because you always measure it in the same fashion. Your mother measures sugar using a spoon before putting it in your milk. She is able to add the same amount of sugar every day because she always measures the sugar in the same way. When you buy vegetables, the shopkeeper measures the mass of the vegetables using his balance and standard weights. Every period in your school has a fixed duration, which is measured using a clock. Everybody makes measurements of some kind or the other. However, the accuracy of measurement varies from case to case. Scientists at environmental laboratories check the amount of arsenic in water to determine if it is suitable for drinking. This amount should be less than 0.0000 gram per liter of water. A very systematic procedure is needed to get precise information about the quantity being measured. Also, scientists all over the world need to express the results of their measurements using a uniform method so that they understand each other. In this chapter, we shall learn about the system developed to ensure that these requirements. Measurement is the comparison of an unknown physical quantity with a known fixed physical quantity. Unit, the known fixed physical quantity is called unit. Or, the quantity used as standard for measurement is called unit. Units are used to measure a physical quantity, such as mass or length. In science, units are an established reference allowing you to define the magnitude of a quantity. Measurements are made to get information about a variety of quantities. Length is one such quantity. One may wish to measure the length of an ant, bacterium, a table, a room, or the diameter of a tennis ball, the distance between the Earth and the Sun, etc. We say that length is a physical quantity. Volume, time, speed, heat, temperature, electric current, etc. are some other examples of physical quantities. We need to define a unit for measurement of each physical quantity. This means that we have to select a particular value, amount, of a physical quantity and say that this amount is 1 unit of the quantity in question. Measurement of a given quantity involves finding out the number of times of the unit the given quantity is. When we state the result of a measurement, we give number as well the unit. Suppose you want to measure the length of a fish you caught and tell your friends how long it is. You select a unit of length that is known to your friends. The centimeter is one such unit. Measurements are made to get information about a variety of quantities. Length is one such quantity. One may wish to measure the length of an ant, a bacterium, a table, a room, or the diameter of a tennis ball, the distance between the Earth and the Sun, etc. We say that length is a physical quantity. Volume, time, speed, heat, temperature, electric current, etc. are some other examples of physical quantities. The system of units that scientists use in most of their work is called Système International des Unités, International System of Units, abbreviated as SI units. There are 7 basic units in the International System of Units. These are the meter, length, kilogram, mass, second, time, ampere, electric current, Kelvin, temperature, candela, luminous intensity, and mole, amount of substance. These are called base units, because all other units can be derived from these units. One of a set of fundamental units in a system of measurement that is based on a natural phenomenon or established standard and from which other units may be derived. The base units of the International System of Units are the meter, kilogram, second, ampere, Kelvin, mole, and candela. A derived unit is a unit that results from a mathematical combination of SI base units. The quantities derived from the fundamental quantities are referred to as derived quantities. The units used to measure these derived quantities are referred to as derived units. Force, velocity, density, heat, power, energy, momentum, and acceleration are some examples. Sometimes, when we express a quantity in SI units, its numerical value becomes very large or very small. The radius of a nucleus is around 10 to 15 m, whereas that of the Earth is about 64,000,000 m. The mass of an electron is 9.1 x 10^31 kg, and that of the Earth is 6 by 1024 kilograms. In SI, standard prefixes are used for certain powers of 10. Lists these prefixes. You are already familiar with some of them, such as milli-, kilo and centi-. We use these prefixes together with to make the numerical values of quantities more manageable. For example, instead of saying that the radius of the Earth is about 64,000,000 m, we can say that it is 6,400 kilometers. Though it is desirable that all scientific work be done using SI units or their multiples with proper prefixes, certain non-SI units are still in use. For example, some common units for length are the inch, foot, yard, and mile, and a common unit for energy is the calorie. The inch is defined as exactly 2.54 centimeters, 1 foot is 12 inches, 1 yard is 3 feet, and 1 mile is 1,760 yards. The energy unit calorie is defined as exactly equal to 4.186 joule. We use certain instruments to make measurements. All instruments have some limitations. Hence, the value of the quantity obtained from the measurement by an instrument has certain uncertainty. With ordinary wristwatches, you cannot measure time with an accuracy better than 1 second. Using them, a time interval may be made as 14s or 15 seconds, but not 14.6 seconds. Anything between 13.5s and 14.5 seconds would perhaps be noted as 14s. Thus, if the measured value is 14 seconds, the actual value could be 14.0 plus or minus 0.5 seconds. This plus or minus 0.5 seconds is the uncertainty of the measurement. When the result of a measurement is stated, the corresponding uncertainty should also be mentioned. Thanks to your patience, friends, for seeing my video. Goodbye until next time.